This is a construction site, or to be more precise, a demolition site. These massive piles of rubble aren't just trash. Did you know that each year, the construction and demolition industries generate over 600 million tons of waste worldwide? That's about 60% of the total solid waste we deal with. But what happens to all this debris after the site shuts down? Simple. It doesn't go straight to a landfill. Instead, it's sent to recycling plants. And from here, we embark on a journey to see how these piles of rubble are reborn into new products, maybe even the chair you're sitting on right now. The recycling journey of C&D waste starts with an essential process: collection and sorting. Don't think it's as simple as throwing wood in one pile and concrete in another. For effective recycling, everything needs to be sorted precisely. That's why advanced sensor technologies like X-ray scanners and optical sorters are here. These technologies can distinguish between wood, plastic, concrete, and metal with up to 95% accuracy. Pretty amazing, right? For every ton of correctly sorted waste, we're preventing tons of CO2 from being released into the environment. Believe it or not, proper sorting can reduce up to 30% of the waste sent to landfills. Just by separating the right materials, we're already making a big difference. Let's start with concrete, the most common material on construction sites. Did you know that concrete can be recycled 100%? These old concrete fragments are fed into crushers with the capacity to handle up to 150 tons of concrete per hour. The machine grinds them into gravel and sand, which can then be used in new construction projects like roads, foundations, or even new buildings. Recycling concrete reduces the demand for natural gravel by 50% and saves up to 1.4 tons of CO2 compared to producing new concrete. Next is wood, an indispensable material in construction. Instead of letting it decompose in landfills, recycled wood can become plywood, furniture, or even new building materials. This process not only protects forests, but also saves up to 70% of the energy compared to producing new wood from scratch. Metal is one of the most infinitely recyclable materials. After being melted down and recast, it can continue to be used without losing any of its properties. Recycling steel saves up to 95% of the energy compared to mining and producing new steel from ore. Each ton of recycled steel saves 1.2 tons of iron ore and significantly reduces greenhouse gas emissions. And of course, we can't forget about plastic, a material we're all familiar with. Recycled plastic doesn't just show up in consumer products like water bottles or shopping bags. It's also used to create drywall or insulation for buildings. Of course, it's not always easy. One of the biggest challenges we face is sorting and dealing with contaminated materials. Sometimes wood, plastic, or concrete gets covered in paint, adhesive, or chemicals, making the recycling process incredibly difficult. In these cases, even the most advanced machines can struggle. About 25% of C&D waste cannot be recycled due to heavy contamination. Another challenge is the uniformity of the waste. Materials from different job sites have varying qualities, and ensuring that all materials meet recycling standards is no easy task. The reality is, not all waste can be recycled. Around 25% to 30% of construction site waste still ends up in landfills due to heavy contamination or the inability to recycle it. This is a major challenge for the industry, and we're still looking for solutions to reduce this figure. Technology is the key. With automated sorting systems using advanced sensors and industrial robots, the sorting process is becoming more efficient than ever. Sorting robots can identify and separate materials within seconds, increasing efficiency up to 98%. That's the future of recycling, and in the future, we'll see fully automated recycling plants powered by renewable energy and artificial intelligence. These plants won't just reduce emissions, but will also lower operating costs, creating economic and environmental benefits. Recycling construction waste isn't just about reducing trash. It's about building a more sustainable future, protecting natural resources, and improving air quality. For every ton of recycled material, we're preventing thousands of tons of CO2 from being released into the atmosphere. Even better, the construction waste recycling industry has been creating thousands of new jobs every year. This doesn't just boost the economy, but also provides opportunities for people working in eco-friendly fields. Talk about hitting two birds with one stone, right? From walls, floors, to furniture, everything can be reborn from what we once considered waste. This isn't just how we build structures, it's how we build a greener future for the next generation. To highlight the effectiveness of the construction waste recycling industry, let's take a look at a few examples. In Rotterdam, the Netherlands, an office building was entirely constructed from recycled materials. The numbers and stories you've seen are just the tip of the iceberg. What we want to emphasize is that recycling isn't a distant choice for the future. It's something we can start doing right now. Anyone, any business can get involved. And it all starts with the simplest step: sorting your waste properly. You don't need a huge project to join the recycling movement. By sorting and handling construction waste correctly at the job site, we're already saving valuable resources and reducing the amount of waste going to landfills. And who knows, the next home you live in or the office you work in could be built from the recycled materials you helped contribute. A sustainable future is within our reach. We're on a journey toward change, and you can be part of it too. Hello, everyone. Have you ever thought about what keeps your car engine running smoothly every day? That's right, it's lubricant oil. But lubricant oil doesn't last forever. After a while, it gets dirty and loses its effectiveness. So what do we do with it? Today, we're going to explore a special journey, the journey of recycling used lubricant oil. There are about 1.5 billion motor vehicles worldwide using tons of lubricant oil. And if you didn't know, just 1 liter of waste lubricant oil can pollute up to 1 million liters of fresh water. But don't worry, there's a much smarter way to handle this problem, and that is recycling lubricant oil. Every day, millions of liters of lubricant oil are used in car engines, industrial machinery, and many other devices. Oil helps protect mechanical parts, reducing friction and preventing damage. But over time, it gets contaminated with dirt, metal particles, and oxidation compounds. When this happens, the oil loses its functionality and needs to be replaced. So what happens when we change the oil? Many people might think it's as simple as just dumping it, but that's a huge mistake. Dumping used oil into the environment can have severe consequences, from polluting water sources to damaging ecosystems. But fortunately, lubricant oil can be recycled and reused. This is not only a way to protect the environment, but also to conserve non-renewable resources. So, how is used lubricant oil recycled? This process involves several steps, each playing a critical role in ensuring the oil is rejuvenated into new oil or converted into other useful products. Let's take a look. The first step in the process is collecting the used lubricant oil. The oil is gathered from vehicle maintenance centers, industrial plants, or even households. After collection, it's taken to recycling facilities and stored in special tanks, preparing for the next treatment stages. Next, the lubricant oil is filtered to remove mechanical impurities like dust, sludge, and metal particles. Basic filtration techniques and centrifuges are used for this. The centrifuge helps separate water and other liquids from the oil, preserving the necessary oil for recycling. Centrifuges work by spinning the oil at high speeds, creating centrifugal force to separate substances of different weights. Water and heavier impurities are pushed out, while the cleaner oil is retained. The most crucial step in the recycling process is vacuum distillation. Here, the oil is heated in a vacuum environment to separate its components based on boiling points. This process not only cleans the oil, but also restores the base oil, one of the primary components used to make new lubricant oil. During vacuum distillation, the oil is heated at lower temperatures thanks to the vacuum pressure. Oil molecules vaporize and condense into fractions with different properties, separating out unwanted components. However, recycled oil can't reach high-quality standards without undergoing hydrotreatment. Here, the oil is combined with hydrogen under high heat and pressure, removing undesirable compounds like sulfur and nitrogen. The result? Purer, more durable oil, ready to be reused. Finally, after going through all the steps, the lubricant oil is finally filtered to eliminate any remaining tiny impurities. The oil is then packaged, ready to be reused, a sustainable and efficient way to handle used lubricant oil. Recycling lubricant oil offers many significant benefits, not just environmentally, but also economically and socially. Let's break it down. Used lubricant oil, if not handled properly, can cause significant harm to the environment. Just 1 liter of waste oil can pollute millions of liters of water, harming ecosystems and human health. However, by recycling oil, we prevent these negative impacts. By processing and recycling, we reduce pollution and protect our water, soil, and air resources. Lubricant oil is made from petroleum, a non-renewable resource. That means each time we use oil, we consume a part of an irreplaceable resource. However, by recycling lubricant oil, we can save precious raw petroleum resources. Recycled oil can achieve a quality comparable to new oil, helping us reduce our dependence on petroleum and natural resource extraction. Recycling lubricant oil not only protects the environment, but also provides significant economic benefits. recycling process produces high-quality oil that can be reused in engines and machinery without needing to manufacture new oil from crude petroleum. This reduces production costs and creates new job opportunities in the recycling industry. Moreover, recycled oil is used in many other industrial applications, such as fuel or lubricants for industrial machinery, creating economic value from a used product. Recycled oil can also be used as industrial fuel. In some processes, waste oil can be converted into light diesel or burned as fuel for factories. While burning oil still produces emissions, modern systems have strict controls that minimize negative environmental impacts compared to traditional fossil fuel use. The concept of a circular economy is one of the most important goals of the 21st century. Instead of producing, using, and discarding, a circular economy focuses on recycling and reusing resources. Recycling lubricant oil is a prime example of this. As used oil can return to the product life cycle, cleaned and restored for reuse, rather than depleting new resources. While recycling lubricant oil brings many benefits, it also faces several challenges. To better understand the lubricant oil recycling industry, let's explore the challenges recycling plants must overcome. Used lubricant oil contains many impurities, including heavy metals, dirt, and toxic chemical compounds. Removing these impurities requires high-tech processes and sophisticated systems, especially to ensure that recycled oil meets the highest quality standards. Building and operating recycling facilities isn't cheap. Plants must invest in advanced technologies like vacuum distillation and hydrotreatment, while also adhering to strict environmental standards. This increases the initial investment cost, making lubricant oil recycling a sector that requires support from economic and environmental policies. However, with technological advancements and increasing environmental awareness, the lubricant oil recycling industry has strong growth potential. More energy-efficient and eco-friendly technologies are being widely applied. The future of lubricant oil recycling will not only help us protect the environment, but also generate new products that drive the circular economy forward. Recycling lubricant oil is one of the clearest examples of combining technology with environmental consciousness. By recycling, we not only prevent waste oil from harming nature, but also contribute to the efficient use of valuable resources. Every time lubricant oil is recycled, we take one step closer to a more sustainable and greener future. So the next time you change your car's oil, remember that used oil can be recycled and become part of the cycle protecting our planet. Recycling lubricant oil for a green and sustainable future. Be part of the solution. If you're a business or individual who uses lubricant oil, don't forget to participate in the collection and recycling of used oil. Every small action contributes to a big change for the environment. Did you know that last night's leftovers might be powering your phone right now? Nope, it's not magic. It's real science. Let's dive into how we turn food waste into clean energy. That's right, from the banana peel you tossed away to the leftover pizza you didn't finish. It all helps create the electricity that powers an entire city. We're stepping into a new era where waste is no longer just trash. It's a resource. Ready to explore? Let's get started. It all begins with collecting and sorting. This isn't as simple as throwing all your leftovers into one big bin and waiting for magic to happen. No. Without proper sorting, the whole process fails from the start. We need biodegradable materials, fruit peels, vegetables, stale bread, things bacteria can work with. These foods are exactly what we need. Plastics, metals? Nope, they don't belong here at all. So sorting properly is absolutely essential. Think of it like cooking at home. You can't just dump all the ingredients into the pot without knowing which goes in first and which comes after. If you don't sort it right, you'll end up with a big mess. Now that the food has been sorted, it needs some pre-treatment. And if you think we just toss all the food into a giant tank and wait for it to break down, think again. The food waste gets crushed into a mixture that's easier to break down. Conveyors feed it into a massive grinder, like a giant blender. Imagine this like preparing a stew. You chop up everything so it cooks evenly. Here, we're not cooking it, but we are speeding up the breakdown process. If you throw a whole steak in here, we're in big trouble. The machine might even cry for help from overload, so we make sure everything is finely prepared. We even add a little water to create a smooth slurry, kind of like adding broth to a stew. Now this mixture is ready for the next step. Now here's where the real magic happens. Imagine we're taking all that food waste mixture and putting it into these huge airtight tanks called anaerobic digesters. There's no oxygen in there, and that's exactly what we need. Anaerobic bacteria, these little miracle workers, start breaking down the food waste. But don't worry, they won't make you sick. In fact, they do the opposite. They create methane gas. Think of them as the best chefs in the world, except instead of cooking up something delicious, they're cooking up biogas. At around 55 degrees Celsius, this process takes a few weeks, and the amount of biogas grows over time. For every ton of food waste, we can collect 100 to 150 cubic meters of methane gas. That's a lot of potential energy we can harness. So once methane gas is created, we need to capture and process it. This biogas can't be used directly. It needs cleaning. Kind of like how you filter coffee, we need to remove impurities like hydrogen sulfide. After the cleaning process, our biogas is ready for use, and it gets piped over to the next stage, turning it into electricity. I always wonder if I could do this at home, but definitely not. These engineers are working hard to ensure the biogas is clean and safe before it's used. Now comes the fun part, turning biogas into electricity. These biogas generators burn methane to power turbines that generate electricity. You can think of it like a giant gas stove, but instead of boiling water, it's generating energy. Each cubic meter of methane can generate about 10 kilowatt hours of electricity. That's enough to power 10 light bulbs for 10 hours. So from your last night's leftovers, we could light up your whole room. But that's not all. After the bacteria finish breaking down the waste, we're left with something else. Organic fertilizer, also known as digestate. This is a super valuable byproduct for agriculture. Instead of wasting it, we can use this fertilizer to help plants grow stronger. This is a perfect example of reuse. We're not only creating electricity from waste, but we're also making fertilizer to nourish crops. A closed-loop cycle. Now you've seen how amazing this process is, right? But let's not get ahead of ourselves. Like everything, this process has its challenges. First off, the cost. Setting up a large system with giant digesters, modern biogas generators, and all the other equipment isn't cheap. And no, I'm not talking about your daily coffee budget. Managing waste is another big challenge. If you don't sort it right, you're in for a disaster. Throw a plastic container in the digester by mistake, and it could mess up the entire system. We can't turn plastic salads into electricity, so make sure everything's sorted properly. It takes a bit of effort and care from everyone, but we can do it, right? Also, let's talk about supply. To keep producing electricity continuously, we need a steady stream of food waste. If we don't have enough leftovers, this plant will be like a phone out of battery. Nothing will happen. And are you patient? Because this process isn't as fast as you might expect. It takes a few weeks, even months, for the food waste to break down and produce enough biogas. That's why we need those big digesters. Not to lock up the bacteria for too long, but to give them enough time to do their job. But while we wait, at least we know the bacteria are working hard, kind of like slow cooking a stew. Good things take time. Finally, our byproduct, organic fertilizer. Sounds perfect, right? But too much of a good thing isn't always great. If not managed properly, it can pollute soil and water. So we've seen both the good and the bad of this process. Even though there are challenges, if managed well, turning food waste into electricity is a fantastic solution to tackle waste and energy problems. Just remember, no system is perfect, but with a bit of effort and care, we can turn waste into something truly valuable. Now go sort out your leftovers before they go bad. Hello everyone. Giant solar farms are becoming increasingly common, providing humanity with a vital source of renewable energy. According to the International Renewable Energy Agency, by 2030, the cumulative value of raw materials recoverable from end-of-life solar panels worldwide is expected to reach around $450 million, equivalent to the current cost of raw materials needed to produce about 60 million new panels. Recycling is a critical solution to reuse valuable materials inside these panels. But how is this process carried out? In today's video, we will explore the detailed journey of recycling a solar panel, from the moment it is dismantled to when its internal materials are reclaimed. Before diving into the specific process, let's first learn about the structure of a solar panel and why they need to be recycled. A typical solar panel has a lifespan of about 25 to 30 years. After that, their efficiency drops significantly, making them less effective for continued use. However, if not recycled properly, these panels can become waste that poses a substantial threat to the environment. A solar panel is composed of various components, each of which can be recycled. From the aluminum frame surrounding the protective glass surface to the photovoltaic cells made of silicon. All these parts have value. Moreover, some thin-film solar panels contain rare metals like cadmium, tellurium, and indium, which we certainly do not want to waste. So how does the solar panel recycling process work? The answer lies in advanced technologies and specialized processes designed to recover these valuable materials. The most exciting aspect is that up to 90% of materials from old panels can be recovered, helping to protect the environment and reduce reliance on extracting natural resources. Now let's dive into the specifics of the recycling process. From the collection, sorting, dismantling, to the extraction and reuse of materials like silicon and precious metals. All steps will be explained clearly but thoroughly, ideal for young people interested in technology and environmental preservation. The first step in the recycling process is collecting and sorting the solar panels. At solar farms around the world, when panels reach the end of their lifespan or become damaged, they are gathered and sent to specialized recycling plants. These are not ordinary waste processing facilities, but high-tech centers equipped with modern machinery. Once the panels arrive at the plant, they are sorted. There are two main types of panels we need to focus on: silicon panels and thin film panels. This step is crucial because each type requires a different recycling process. Silicon panels are the most common on the market, accounting for about 90% of solar panels currently in use. They are made from multiple layers of materials, with the most important being the silicon photovoltaic cells that convert sunlight into electricity. On the other hand, thin film panels are less common, but contain rare metals like cadmium and tellurium, requiring a more complex process. So how do the recycling processes differ for silicon and thin film panels? For silicon panels, the focus is on recovering silicon and other materials like aluminum, glass, and copper. Meanwhile, thin film panels require chemical treatments to extract precious metals. This sorting step is crucial because failing to separate the panels by type would make the recycling process inefficient and could result in wasted valuable resources. Advanced technology is key to maximizing the use of these resources. Modern recycling plants can process thousands of solar panels each day with a sorting accuracy rate of up to 99%. After sorting, the next step is dismantling. This process begins by removing the larger components like the aluminum frame and wiring. Aluminum is one of the easiest metals to recycle, and we can recycle 100% of the aluminum from solar panels without losing any quality. Recycling plants use specialized aluminum frame cutting machines to ensure that the dismantling process is quick and precise. These machines not only speed up the process, but also protect other components of the panel from damage. Next, we'll look at how these materials are efficiently processed and reused for new applications. Glass is a crucial component of solar panels. It protects the photovoltaic cells inside from environmental factors and helps increase the durability of the panel. Making up about 75% of a solar panel's weight, glass can be recycled up to 95%. But to do this, we must separate the glass layer from the other layers of the panel without damaging them. To separate the glass effectively, we use specialized glass separating machines. These machines are designed to remove the glass layer without damaging other components, particularly the silicon photovoltaic cells inside. Once separated, the glass is processed in standard glass recycling systems. Modern glass separating machines can process thousands of panels per day with high precision and minimal waste. Recycled glass from solar panels can be reused in various industries. After separating the glass, we come to the most important part of the silicon panel, the silicon photovoltaic cells. This is where the conversion of sunlight into electricity takes place. Silicon is one of the most crucial materials in the solar energy industry and one of the most valuable components to recycle. The process begins by crushing the panels, which are fed into crushers that break them into small pieces. The mixture of crushed materials is then passed through sieves to separate them by size. The smaller particles are fed into an electrostatic separation chamber. In this chamber, the particles are exposed to a source of electric charge, which can be either a charged electrode or a spark discharge. This process causes the particles to carry different charges. A strong electric field is created in the chamber. This field affects the charged particles, causing oppositely charged particles to attract and like-charged particles to repel. The particles with different charges move along the electric field lines and are collected at corresponding electrodes. Finally, we recover aluminum, copper, and silicon powder. Now we move on to thin film panels, a more specialized type of solar panel that requires a more complex treatment process. To recover precious metals like cadmium, tellurium, indium, and gallium from these panels, we use a chemical process. The first step in processing thin film panels is to grind them into small pieces. Industrial grinders cut and crush the panels into smaller pieces, increasing the surface area, which makes the following chemical processes more efficient. Once crushed, the panel fragments are placed in a chemical bath, where the precious metals are dissolved into a special chemical solution. This process not only extracts the metals, but also cleans impurities. Chemical baths use acid solutions or organic solvents to extract precious metals from the panels. These systems can recover up to 95% of the valuable metals, making the recycling process both efficient and economical. The precious metals, once extracted, are refined and reused in the production of new thin film panels or other electronic devices. This reduces reliance on new resource extraction and helps protect the environment. Not all components of solar panels can be recycled. Some materials, like EVA plastic and polymer films, cannot be reused and need to be treated as industrial waste. These materials are incinerated in specialized waste incinerators. The incineration process helps recover energy from waste and reduces its negative impact on the environment. The energy recovered from waste incineration can be used to power the plant, making the recycling process more sustainable. Additionally, modern recycling plants optimize their processes to minimize the amount of waste generated from each panel. Waste incinerators can process hundreds of tons of waste materials per day and can recover up to 50% of the energy from the incineration process. This helps reduce the amount of industrial waste that needs to be managed using traditional methods like landfilling. While the solar panel recycling process has made significant progress, the industry still faces many challenges. The first challenge is cost. Recycling requires advanced technology and modern machinery, which increases operational costs. Additionally, the value of recycled materials like silicon or aluminum often does not offset the production costs. Another challenge is the scale of recycling. With the growing number of solar panels worldwide, expanding recycling facilities is necessary. However, building and operating a recycling plant requires large investments and modern technology to efficiently process the growing volume of panels. Moreover, environmental regulations pose a major challenge. Each country has different regulations for handling electronic waste, and recycling companies must comply with these rules, complicating the recycling process. Another challenge is public awareness. Although solar energy is considered a green energy source, many people are still unaware of the importance of recycling solar panels. This leads to many panels being discarded instead of being properly recycled. Addressing these challenges is not only the responsibility of recycling companies, but also society as a whole. We need investments in technology, increased awareness, and effective recycling systems to protect the environment and make the most of our resources. In today's video, we have seen the importance of recycling solar panels. This process not only helps us conserve resources, but also reduces the amount of electronic waste, which is one of the fastest growing types of waste globally. Recycling also reduces the dependence on extracting new resources, protects the environment, and minimizes pollution. Furthermore, it creates new opportunities for the green industry, from developing recycling technologies to creating products from recycled materials. However, to achieve this, we need cooperation from multiple parties. It's not just the effort of manufacturers and recycling companies, but also the active participation of the public. Awareness of the importance of recycling and taking specific actions will be key to building a more sustainable future. Hello everyone, today we're diving into a unique and critical process in the recycling field. The air conditioner radiator recycling process. Each used air conditioner, despite its age, holds valuable resources. Have you ever wondered what's inside an old air conditioner and how we can maximize its value? Inside every air conditioner, there are metals like copper and aluminum, both of which can be recycled almost infinitely without losing quality. However, the recycling process also needs to be environmentally safe because these units contain refrigerants that can severely damage the atmosphere if released. Today, we'll take a closer look at each step in this recycling journey, from recovering refrigerant gases to metal separations and melting. According to the World Health Organization, WHO, refrigerants like R22 can significantly harm the ozone layer, which shields Earth from harmful UV radiation. Thus, this recycling process is not just about reusing metals, but also about protecting the environment. The first step in the recycling process is refrigerant recovery. Gases like R22 and R410A, found in air conditioners, can cause considerable damage to the ozone layer if they leak. To ensure absolute safety, we use specialized equipment and a team of experienced technicians. This machine can recover up to 98% of refrigerant in just 15 to 20 minutes. This machine works by creating a closed loop that extracts and stores the refrigerant in special cylinders, preventing any gas from escaping. One significant fact to note is that only 1 kilogram of R22 release can damage the ozone layer, as much as 1,800 kilograms of CO2. So, refrigerant recovery is not only crucial for reuse, but also for environmental protection. This process is particularly important as any error can lead to refrigerant leaks with severe consequences. That's why every recycling facility must strictly adhere to safety regulations. After refrigerant recovery, we move to the next step, dismantling the radiator. Did you know that inside the radiator are copper tubes and aluminum sheets, both highly recyclable metals? For effective recycling, the technician unscrews and carefully removes parts, ensuring that copper tubes and aluminum sheets remain intact. This maximizes the recyclable metal and minimizes waste. Aluminum and copper are highly durable and conductive, and recycling them can save up to 95% of the energy needed to produce new material. An average air conditioner contains about 1 to 3 kilograms of copper and around 2 to 5 kilograms of aluminum. These are valuable resources for various industries, including electronics. Next, we proceed with metal separation. The radiator's structure alternates between layers of aluminum and copper to optimize heat transfer. To separate these two metals without compromising their quality, we use an automatic separation machine, the radiator copper and aluminum stripper. This machine uses a cutting and pressing system to separate the aluminum and copper layers without deforming them. With a capacity of up to 300 kilograms per hour, this process minimizes human labor and ensures high-quality recycled products. This separation process not only recovers all the metal, but also preserves the quality of copper and aluminum, ready for further processing with minimal cleaning. After separation, we move on to a crucial step, shredding and melting the metal. First, the aluminum and copper are shredded into small pieces to facilitate the melting process. This shredder processes metal at a high rate, handling up to 1,000 kilograms per hour, saving both time and effort. Once shredded, the metals are sent to the furnace. The furnace reaches 660 degrees Celsius for aluminum and 1,085 degrees Celsius for copper. As the metals melt, impurities are removed, resulting in high-purity recycled ingots ready for reuse. Besides aluminum and copper, other materials like plastic and rubber from the radiator are also separated and processed. Some plastics are shredded and recycled into other products, while rubber can be repurposed as industrial fuel. This recycling process not only reclaims valuable metals, but also reduces electronic waste, helping protect the environment and conserve resources. So we've covered the entire radiator recycling process, from refrigerant recovery to metal separation, shredding, and melting. It's amazing to see how each old air conditioner can become a new resource, contributing to a sustainable economy. Recycling not only conserves resources, but also allows us to protect the environment and build a greener future. In our surroundings, roads are among the most common yet overlooked features. They are hard to miss, but most of us rarely consider how they are created. Delving deeper, there is no definitive answer to the question, what is a road? It turns out there are many ways to build a road. The writer Lu Xun once said, "Actually, there are no roads on Earth. They are made by people walking one after another." In the modern world, asphalt concrete is the most commonly used material for road construction. Have you ever wondered what happens to the old cracked roads you pass by every day? Are they left to decay, or can they be reborn to become part of the future? Let's find the answer in today's video. Asphalt is the most commonly used material for road construction worldwide. But why? Asphalt consists of two main components, crushed stone and a binder mixture, primarily bitumen, a fossil fuel found in natural asphalt pits. Bitumen has been used by humans for thousands of years for waterproofing items, building stone walls, and sealing boats. The first recorded use of asphalt for roads might have been in Babylon over 2,500 years ago. In the US, asphalt appeared in the late 19th century, and within decades, demand outpaced the supply from natural sources. As a result, asphalt began to be produced from crude oil. Asphalt concrete meets numerous requirements for modern roads. It is easy to apply and source. It provides excellent tire grip without requiring grooves, meaning it is relatively quiet, important depending on the location. It is flexible, allowing it to adapt to some subgrade shifts without damage. It is also easy to repair and can be used immediately after placement. A 500-meter cracked road can be patched with asphalt in less than 2 days, whereas repairing it with cement concrete could take a week or more. Unlike many other construction materials, asphalt is almost 100% recyclable. However, statistics show that over 70% of asphalt in the US is not recycled. Authorities fear that adding too much recycled material could weaken the roads. In New York, for example, 1 million tons of old asphalt are removed annually, but only 30% is allowed to be recycled. Asphalt has a lower construction cost than cement concrete, and its life cycle is longer when recycling capabilities are considered. Asphalt recycling is a series of carefully executed steps, not only to reduce waste, but also to create more sustainable roads. Let's explore each step. The first step in the recycling journey is collection. At the site, specialized machines scrape off layers of old asphalt 5 to 10 centimeters thick. The old asphalt is transported to recycling plants where it is crushed into small granules ranging from 5 to 25 millimeters. Impurities like soil and debris are removed, ensuring the recycled material is clean and uniform. The asphalt fragments are then screened into 3 sizes: black sand, small stones, and large stones. The recycled asphalt is mixed with new asphalt, stone aggregates, and additives to form a new asphalt mixture. The asphalt mixture is then heated to temperatures of up to 150 degrees Celsius, ensuring optimal pliability and adhesion. This plant can produce 300 tons of asphalt per hour. During the process, a small amount of paraffin oil is added to restore the properties of the old asphalt. Statistics show that each ton of recycled asphalt saves 3.8 liters of crude oil and reduces CO2 emissions by up to 20%. The final mixture is temporarily stored in silos and must be used within 24 hours as it hardens when cooled. After mixing is complete, the asphalt mixture is delivered to construction sites and spread evenly on the road surface. Each layer of asphalt is compacted, creating a smooth and durable surface. Asphalt recycling is not just a smart choice, it seems to be a mandatory solution for a sustainable future. It minimizes waste, conserves resources, and protects the environment. However, it also faces challenges. Dust and smoke during the recycling process can create air pollution, affecting human health. Many asphalt plant owners also operate quarries and crude oil supplies, giving them little incentive to recycle since it affects their revenue from primary products. The story of asphalt never ends. From an old, worn-out road to a new foundation, asphalt tells a tale of rebirth, sustainability, and the future. And because asphalt will continue to be used for a long time, maximum recycling is essential. Who knows, the next road you drive on might have been recycled. Hello everyone, welcome back to IronHand Tech channel. Today, we will explore an exciting journey. The journey of recycling aluminum core wires. Looking at these old wires, do you think they can become a valuable resource? The answer is absolutely yes. These seemingly discarded wires are actually hidden treasures with aluminum metal that can be recycled many times without losing quality. Follow me and learn the whole process. Aluminum is one of the most widely used metals globally. It's lightweight, durable, and corrosion-resistant, making it essential in industries ranging from construction to consumer goods and electronics. But perhaps the most remarkable fact about aluminum is its nearly unlimited recyclability. It can be reused countless times without compromising quality. And here's the kicker. Recycling aluminum uses only 5% of the energy required to produce new aluminum from bauxite ore. This means that recycling not only conserves natural resources, but also significantly reduces greenhouse gas emissions, helping protect our planet. Today, I'll guide you through each step in the aluminum wire recycling process, from collecting and sorting to stripping, shredding, melting, and finally casting new aluminum ingots. Let's get started with the first step. It all begins with collection and sorting. Here we are at a large collection site where wires from various places are gathered. These wires come from a wide array of sources: construction sites, power plants, and retired telecommunications networks. Effective sorting is essential for efficient recycling. At this stage, aluminum core wires are separated from other types of wires, particularly copper wires. Sorting can be done manually or using automated systems, depending on the facility's scale. At smaller facilities, workers handle each wire manually to ensure no mix-ups occur. After sorting, aluminum core wires move on to the stripping stage. Now we're moving on to stripping the plastic or rubber insulation. As you can see, each wire is coated with an outer protective layer, either plastic or rubber, to insulate and protect the aluminum core. This is the stripping machine, a crucial piece of equipment that removes the outer plastic without damaging the aluminum core. This machine uses high-precision rotary blades, capable of handling wires with diameters from 1 mm to 80 mm. As the wire passes through, the blade carefully cuts the sheath, leaving the aluminum core intact. For wires with unique sizes or materials, skilled technicians may step in to ensure the aluminum remains undamaged. Once stripped, we have pure aluminum cores ready for the next steps. This precise stripping stage sets the foundation for high-quality recycling. Next, we'll shred these aluminum cores in preparation for separating the aluminum from any remaining plastic. Now we move to the shredding stage. This step reduces large aluminum sections into smaller particles, preparing them for the aluminum-plastic separation phase. This aluminum shredder has a high capacity, processing hundreds of kilograms of aluminum per hour. The particle size ranges from 1 to 3 millimeters, perfect for sorting and separating from any remaining materials. With the shredding step complete, we're all set to advance to the next critical stage, electrostatic separation of aluminum from plastic. Next, we use electrostatic technology to separate aluminum from any remaining plastic particles. This system works on electrostatic attraction, enabling the clean separation of aluminum from leftover plastic. As the aluminum and plastic particles pass through, the electrostatic field attracts the aluminum away from the plastic. This system is incredibly efficient, achieving a 99% purity level in aluminum separation. This way, we guarantee that the aluminum obtained is perfectly pure and ready for the melting phase. Next up, these pure aluminum particles go into the melting furnace. This is a critical phase where the aluminum is heated to temperatures of 660–700 degrees, eliminating any remaining impurities. Modern melting furnaces ensure that the aluminum melts quickly and evenly. This temperature is ideal for clearing out impurities, prepping the aluminum for the final stage, casting. After fully melting, the aluminum is poured into molds to create new ingots or plates, ready for industrial applications. Now we reach the final stage, casting aluminum ingots. The molten aluminum is poured into molds to form ingots or plates of various sizes and shapes. After casting, the aluminum ingots are quickly cooled with water or air to solidify. These ingots are now ready to be used in construction, automobile manufacturing, and many other industries. And that completes the recycling process. From seemingly worthless wires, we now have high-quality aluminum ingots ready to re-enter the industrial life cycle. Recycling aluminum from wires not only brings economic value, but also has a profound environmental impact. By recycling aluminum, we reduce the demand for mining bauxite, a non-renewable resource. Moreover, the recycling industry creates jobs and drives the green economy. This is a crucial step towards a sustainable circular economy. And there you have it, the complete aluminum wire recycling process. From collecting, sorting, stripping, shredding, separating aluminum from plastic, melting, and casting, we've journeyed through each stage that completes the recycling process. This shows that with some effort and technology, we can protect resources in our environment. Thank you for joining us on this journey. Let's all support recycling initiatives as a greener, more sustainable planet begins with small, meaningful actions. See you next time.